this is a lesson in which we'll conduct our experiment. This is how to conduct the experiment with regarding to the shape of an object in water. You should have already seen the videos on how to choose your containers and then how to calibrate and fill your container. So now we're starting with actually doing it. Before we actually do it, let's take a look at what we're doing in a different light. This is not exactly what we're doing, but what we're doing is the beginning of this, and this actually takes calculus to do. But here's how we're talking about it so that you'll see what we're doing. Okay. We're going to have an object in the container and then fill it with water. Notice as you fill it with water how the amount of space available to put water in changes. So if I put water up here to my green stick, there's not a lot of space into which to put water. As I move up, now there's considerably more space to put the water in, and the curve goes up fairly sharply. At some point, as we get up, it levels out some. Now you might think that ought to be a straight line because this is a straight line. Well, I save that question for calculus. It has to do with this being in 3 dimensions and this graph being in 2. Same deal here. When we start down here, there's quite a bit of space to put the water in. As we go up, the amount of space increases, but it doesn't increase quickly till we get up in this region. If the water line were here, now there is not much place to put water. Not much place to put water means when you pour in the same amount of water, it's going to go up fast. So here, that's indicated here. That would be that portion of it, and then we get to the top of it. Same deal here. You would come through and see how it's going up. A reminder of the things that you'll need to conduct this experiment. Here's what you've got. Okay. You'll need to have a container with straight parallel sides that will hold water. In the other video I said it needed to be perpendicular to the base. It doesn't really have to be perpendicular to the base, but if it is, it won't fall over. Geometry students will learn here in a week or two Cavalari's principle, which says it really doesn't matter if the sides are perpendicular as long as they're both straight and parallel. Okay. You'll need an object. It needs to be mostly symmetrical in 3 dimensions. And so I have an example of an object here. Here's a good object. Okay. What I mean by symmetrical in 3 dimensions is that when I do a vertical line, that it's going to be basically a mirror image on both sides. It doesn't have to be perfect. This one is pretty close to perfect. So it is symmetrical, and as you turn it, you see, oh my goodness, look what you see. You see how really unique and rare this particular bottle of Coke is and why I haven't drunk it. Rice Owls, that's Rice University, were national champions. Folks, this happens like really rarely that Rice, wins a ball game. So this was really cool. And see, I went to Rice and I was in the band, and the band sometimes was the major attraction for the football games anyway. But anyway, we all had a good time and we were glad to have the games. All right, so the idea here, I digress, was an object that'll keep water out and is basically symmetrical on a vertical axis. You'll need a cup. I'm just going to use a measuring cup, but any small container will work. And you need a ruler. Centimeters is probably easier for this calculation, but you can use imperial units if you like fractions. Okay. There are a lot of times when imperial units are easier to use, but this probably is not one of them. So you're going to graph, and you'll need graph or make your own. That would kind of be neat if you'd make your own, but you don't have to. Okay, what we're going to do is we're going to pour our cups of water into the container several times. And the other one you told how to do that, talked about how to do that. And each time we're going to pour the same volume of water. Okay, now here, just concentrate on Froggy while a minute while I go get something. Hey, Frog. There he goes. So I can show you about how to pour the water, what it does. got, I've got 2 equally sized containers here. And I'm going to show you about pouring water into it and how that happens, or pouring something in it. These are both olive jars, and they're both the same volume. But what we'll see here is that my iced tea doesn't come up the same way. So what I'm going to do is I'm going to take my standard cup that I'm using and pour it into each one of them the same amount. As I talked about in the other video, it's easier if you have one that you're using at the standard, but it doesn't matter if you want to measure it every time. That'll work too. I pour one of my standard units into it, and what do we notice? Oh my goodness, this one came up this far, but this one came up this far. Oh my goodness, why could that be? Could it be because there are rocks in this one? Yes, there are rocks in that one. Since there's rocks in this olive jar, the water comes up higher because the rocks take up space. Well, the iced tea I'm pouring in is a unit of measure, is a set volume, the same set volume for the no rocks and for the rocks, but since the rocks are taking up part of the space, part of the volume of this olive jar, the water comes up higher, the iced tea comes up higher. So then, what do we have here? If I do notice what happens when I do it again, and this is going to apply to what you're doing, I'll pour this in here, how much it came up from where it was before, and I'll do it again here, how much it came up from where it was before. It came up like this much this time, but this one already also came up about the same. So what we had there is in the second iteration, the volume was approximately the same that was filled here. It didn't have rocks in it, so the water went up at the same rate. The iced tea went up at the same rate. Okay, so that's what you're going to be doing. And if you do it again, it'll be the same. This one will come up at about right here. This one will come up, if I measure it, the same number of centimeters. Why? Because there's no obstruction there. What we're doing is graphing the effect of the obstruction. Okay? So back to Froggy. Here we go. Now, okay. So what's going to happen now, I'll show you as I get this set. Here we go. So this is what your assignment is, and I'm going to show you a little bit more about how to do it. You're going to pour the cups of water into the container several times. I just did it twice. And you'll graph how high the water is each time the water is added, and then you'll analyze your results. What will that look like? You should draw a graph basically like this. You're going to graph volume versus height. So you'll have the input, the independent variable, the cubic units of water added. Okay, the cubic units, that's going to be your cup, whatever you're using. Okay, this is one of my units. It's a third of a cup. So you'll use whatever yours is. So you won't be doing this in milliliters or ounces or anything like that. You'll be doing it in your standard unit. My standard unit is a third of a cup. It's this cup. That was in the other video. And then what you're graphing against is the height of the fluid in the container. That's what you're graphing. For each iteration, each time you do it, you should graph one point and label them as successfully A, B, C, D, E, F, G, H, I. How many ever it takes. I've told you to have a container that'll hold 20 approximately of your individualized units, cubic units, but you probably won't use 20. Because the same real deal with rocks here. The rocks take up some of the space, and whatever your object is going to take up some of the space. So you're probably not going to do it 20 times. So for this graph, when I poured in 1 unit, my standard unit, my cup, it went up this high. And you'll need to put your units here. Depending upon the size of your container, you'll want to make this appropriate so that you can fit it on the page nicely and have a good presentation. Then after the second time here, the third time here, the fourth time here. Okay. This isn't any particular shape. I just kind of made this up. So if you're trying to make it look like a particular shape, it won't. After you've done that, please go ahead and connect them with line segments, straight line segments. Now, you can do this if you want, or you can do it the other way if you want. Generally speaking, it's planned for you to stop when you get to the top of your object, but it could be kind of fun if you want to go ahead and go beyond the top of the object and see what happens. Just make sure that you describe adequately what you've done and accurately. Okay. So what you see here is the beginning of the curve that I showed you as I started with regard to calculus. This is not a smooth line. It's a piecewise function composed of straight lines. However, if you were doing it and you were learning your calculus, then you would go back and do it again and see what would happen if you just put half of a unit and then a fourth of a unit and then a third of a unit. And I think you can see that it would not be possible to do it for every point on this curve. That's why we need calculus. So when you get to that, you do it. Okay, so you will label them with letters, and then you're going to put the same idea here. So here, this is how high it was at A, how high at B, how high at C, the height being here. Then draw your item. Here's my Coke bottle. Draw your item and mark approximately how high up on it was when you just put one thing in. So A would be the first iteration, the first time I put in my cup. And I need to be careful to notice what it looks like and make a mark of it. So you might want to draw this object before you do the experiment. And then in each one of them, some of them may be spaced evenly and some of them may not, depending upon the shape of your object. Okay, once you've done this, you're going to have a weird looking graph. Again, it's going to look like this. It's not going to look like a Coke bottle or whatever your shape is. It's going to be this piecewise function of straight lines. That's the experiment, and here's what you do to report on it. Look at it. Figure out what's going on. Check out the characteristics of your graph and how the points relate to the location on your drawing. Okay, well this doesn't match my drawing, but if it did, you could see that from here to here, there's less volume, less space available, so the water goes up faster. That means it's bigger. It's out close to the edge. So if it were the Coke bottle, that might be a part where it's getting bigger. Because there's less space. Remember, the container's over here, and you're putting your water in the space. So if there's less space, it goes up faster. It'd be good to describe in general terms how the slope changes. You don't necessarily need to calculate the slope, but just describe how it changes and what that means for the shape of your item. Once you've done that, you're going to write a paragraph. You should actually use words, like subjects and nouns and maybe a preposition. And you really go hog wild and put an adjective in there. Okay. Write a paragraph telling how the graph relates to the drawing. Include reference to such things as the change in the slope of the lines and other things that have to do with it. Okay, once you're done with that, find a friend, presumably one who's already done the experiment and done this part, because they won't be able to do this if they don't know what they're doing, or you could explain a whole lot to them. So, show your graph to your friend, but don't let them see the object yet. No, secret object. It's probably better to choose a friend that's already done the experiment. Ask them to try to draw the object from analyzing your graph. They might need to be reminded that your object is roughly symmetrical about the center. That will help them figure out how to draw it. Okay? Then once they get it drawn, go ahead and show them the your object and see how close they were. And if they're really close, yay! And if they're not really close at all, you can just kind of laugh at it. It doesn't need to be close. It's the whole point of this is getting you to think. Getting you to think and to understand the relationship between the math and the object. Once you're done with it, turn your experiment in on the hub. Be sure to include the graph, your drawing of the object with the water levels marked, your explanatory paragraph, and your friend's drawing of your item based on your graph. Okay, not their drawing of their objects, but their drawing of your object that they tried when they were doing their graph. And I think I'll go have a Coke, but not this one because it really is a classic. Here in the lesson.